Hi everyone, I'm happy to be here today and to present this lovely testing session. So I will start with a presentation to cover like testing types, and then we will have another part which we will write unit tests, and the final part will be end-to-end testing. So the end-to-end testing is like really important. What you did so far, we will test your code, what you have already. So yeah, we can start. Can someone check Slack if people has questions?
Of course. We can all do that.
Yeah, sometimes we miss it. Okay, so yeah, let's start with our presentation now. Before that, let's just talk about like your experiences. I watched before the session of last year, and I think I was there as well. And I know that like some of you already have an experience of testing. So anyone has any experience on testing so far? Okay, you, okay. So what kind of testing you did?
I did also unit, but with Java.
Okay, perfect. So what kind of tests you wrote, like units or?
Like expected result and the real result.
Okay, so those are the topics that we will cover today as well. And yours? Mobile testing, is it like a UI testing or did you write unit tests? Like a manual testing? Okay, so no, it is
with a device, right? With a phone, clicking around the phone and making sure that it's actually working.
Mm-hmm. Yeah, that's also the quality testers' job to do it, but sometimes they also automatize how we do this. Anyways, and yeah, there as well.
Did unit testing for basically test-driven development and also automated test for API calls.
Mm-hmm. Okay, so actually, like all you mentioned are like our topic today. We will cover all of them. Is there anyone else who is used to? Okay.
I've written some RSpec tests.
RSpec.
Okay. So what were you testing there?
Mostly inputs and the expected output from the method.
Yeah, good. Okay, so maybe other people can also share their opinions, like why do we need testing? What do you think about this? Like, anyone wants to share?
What does it actually mean, testing? Obviously, we know the dictionary definition of what testing is, but why is it important enough that we cover it in our classes?
Okay.
It's important because you need to make sure that your application doesn't break surprisingly. You need to test every component, every kind of functionality you can test to functioning, whatever.
That's true. And then, yeah, you can also.
I'd like to hear what you want.
I thought you want to add something, but like that's true. Like a function should work, and as you also mentioned that like it should work in an expected way. So how we do it is like we have some scenarios in our minds that like, okay, this function, I want this to be working in this way. So how do we do it is we just say, I'm giving this input to this function and I'm expecting this result. It shouldn't have different results because then we have bugs. So and the development process is like you already have probably that like you write your code, and then when there is a problem, you always have this struggle to understand what was the problem, why my code is not working. This is all about testing. If you write more tests, when you change your code, the possibility that like you understand which part was wrong, it's much easier than the like also before the problem exists in the real system. for example, you write a code and you submit it and it's live now. And if you don't write your tests, probably it will be somewhere a user will have a, error screen and you won't even know it if you are not logging it or like if you are not writing your test. So the idea is that we expect our code to be worked in a correct way, and we have to assure it before that, like we get a crash log from somewhere. Before that, we have to be sure that it's working in our test systems. Okay, so
yeah, the idea is basically there is no error-free software. Every piece of software will have bugs in them, and the idea is let's discover them before it hits the user and before the user starts swearing at us. And because they want to do some money transactions or they want to attend the meetup. And what if your software, meetup.com, cannot register people who wants to attend the meetup? And they get an error page that says, "Oh no, sorry, there's an error in the system. We don't even know what the error is." So like these things have to be prevented in order to have a quality of service. Like whenever you send an email on Gmail, for example, 99.999% of the time, you're able to do so. If you can't, you know that your internet is down or something. Like the problem is actually with you and not with Gmail. So the idea is we make sure with, like in multiple stages, that our software is behaving as it should. And we have certain metrics to check that these are in place. And like Miri will talk about those in a little bit, but the idea is we try to get a percentage number that tells us that, hey, your software is probably good. I checked every single line in your code and it's probably working. We cannot be 100% sure, of course, but at least we can get a certain number of confidence in the ability or the correctness of our code base.
Mm-hmm. Okay, so let's start with unit testing. As you can see from the name as well, you have your code like a unit part of it, like a it could be a function or a chunk of functions. Then, but it's a standalone function, and you try to test it isolated from other behaviors of your whole program. So we will check an example. What does the first line do here? Can anyone say? Do you want to say?
The first line in the code.
It adds A and B together and returns what it is.
Yeah, it's a sum function. This looks like a really simple piece of code. And this is exactly what unit is. This is a unit of code that you want to test. And then what you do is like you have your test name there. We will go through this. We will write this code, by the way. It's just like an example now, but we will do it hands-on. And the name of the test is sum of two numbers. And then you see result. So this is the result of the actual result of the function. And then we check T is, and it says like result 3. So it means I expect the result to be 3. So I check the input and the output in a way, like the expected and the actual. And if it's the same, it means my test passes. This is clear. So here the important thing to keep in mind is more that like you need to somehow scope down the functionality so that you can have an isolated input-output system. So if you think about it, if you have a complex functionality which starts from somewhere and you have lots of operations that you do. Let's say that like you fetch the weather information from Google API and then you do something with it, and then you check the humidity, and then you have some more data, and you have lots of calculations, and in the end you have a result of it. This doesn't fit to unit testing, right? Because there are lots of things and possibilities which can change the result. So it is really important that like unit tests can be written for units which would give the result that you expect, or you can rationally check this. Is it clear?
The word test is already included in the terminology of JavaScript.
Yeah, it's a
No, in fact,
package.
that's coming from a library that we're going to use. And you'll see in a few minutes that it's like import tests from a library, from Ava. And then we're going to be able to write it. But there are some languages that have built-in structures for testing just like this. The idea is, let's discuss this sum function. It takes two parameters, A and B, and just returns the summation of it, right? Why do we need to test it? Why would you even write tests for it, please?
So, a few reasons, but one I can think of off the top of my head is that as a developer, you want a certain level of confidence in your code to ensure that when you change something, one, you know where a bug is located, and you also know that that change didn't impact the intended behavior of your function.
Yeah.
Could it also be that you could pass in unexpected things?
Definitely. Yeah, so this is really important. When you are writing tests, you should be able to provide lots of inputs, and it's good to have edge cases for that case. So for example, if I send AB with strings, hello, hi, so if A would be hello and B would be hi, what would be the result? For example, what would be the result of this function? Would it crash? Would it, so in the end...
Not the number.
Huh?
Not the number.
Yeah, okay.
No, in fact, you can sum up strings and it just adds them together, so it would be hello, hi.
Yeah.
But obviously, that's not what we expect. So, yeah, if you want to multiply the results, then like a string, of course, it's not going to work.
Yeah.
So what we do, in fact, is not only for the heavy path, where you can add 1 and 2 together and get 3, we also test for edge cases like these. What happens when I want to sum not a number with a number, or a string with a number? And do I still get the actual computation that I want? Obviously, you may want to throw an error if somebody passes in a string. You might say, I only accept numbers, and that's also possible. That basically depends on your intentions while writing this function. Or you could also say, even though there's a string, I'm going to convert it into a number and then use it. And then you would have, then passing in a string would be a valid thing to do with your function. But then you would have specific tests only for that case to make sure that, again, somebody cannot maliciously alter the output of your code, or by giving weird input or unexpected input, and they're not breaking your code. In fact, even though this function is just like 3 characters or something, depending on the actual use case, the tests could be like 50 different tests with different inputs and different types of inputs, depending on obviously how important this function is for you. And again, I want to go back to the discussion. I will come back to this throughout this lecture. You will never be able to make sure that it's actually acting correctly, 100%, all the time, please.
There was a notification about the mic. Please check whether the mic is working or not.
Ah, yeah, it's fine.
It's fine.
Yeah, we turn off the mic always. Otherwise, there's feedback in the room. So the idea is, please.
So it also says that T is result 3, but do you always know the result? So now we know that 1 plus 2 should be 3, but in a more context?
So you will always know it. That's the goal. Unless you're doing some random computation, then things would get really, really complicated. But the idea of testing is you know what input that you want to get to the system, and in the end, you are 100% sure what you want to get out, or at least is it something within a range? Let's say there's a function that calculates the upper bound and lower bounds of a range of mathematical calculations, then obviously there is no fixed number and there is no fixed output, but you would at least check if the output is greater than what you were expecting or like smaller than what you were expecting. So there has to always be an output that you're looking for, even if it's not exactly something that you can define, like 3.
So, for example, I think this string was a good example. You can say with hello and hi, I want my code to work as it becomes hello hi, or you can convert them to numbers. So there comes test-driven development actually a bit, because then when you think about some cases, you can also at that moment decide what you expect as well. So you can say, okay, I want my function to behave like this, and then you start writing your code based on that. So that was a good example on that. And also what you mentioned, maybe even for this function, if you would change something, if another developer comes and changes plus to minus accidentally, your test would run, and then you would see, okay, something changed and something failed, and then you would know what is the reason for it. So this is always good to have tests, like it's not for this function, but like in general why we need testing. Because maybe in your job experience, or like in general, like sometimes we developers say, okay, it was working, I didn't change that part, you changed only that one function, and then all your code starts working differently, and you can't find why this is happening, why is it affecting something else. So if you write tests, there is a possibility to understand it before.
And obviously it's very boring. It's extremely boring to write tests with hundreds of different inputs where you can never be 100% sure. You can just increase your chances to be correct, and decrease your chances of having a bug in your system. And that's why not every developer does testing, let alone test-driven development. And that's why it's a very important skill to learn, because if you can master testing and if you can master test-driven development, then you'll be a very sought-after engineer in your teams. Because in the end, everybody obviously wants bug-free code, right? But nobody takes the effort to learn proper testing and to implement proper testing. And if you're that person who knows how testing works and how you should approach it, and the best way to write your tests and make sure that the system is fine, then not only will you be able to rise really quickly through the ranks of software engineering, but also your friends, your colleagues will love you, because you're basically going to save them. And you can always, obviously, hopefully talk about testing and how good it is in your companies, in your teams, and pester them and make their lives harder with this boring stuff. Please.
Also, another question. You mentioned that I have a very complex function, and it would be difficult to test it with unit tests because it's too complex. So does it mean that I have to chunk my function into smaller pieces?
Yes.
Or do I need another
there are
system?
Actually exactly what you are saying, because you would either chunk it to smaller pieces, or you would take it as a box and then test the expected and actual again. So you would think it is a function, I don't know what it is doing, but I always expect this results from this piece of code. So for that, like we have end-to-end testing, and also the integration tests are a bit like that as well. But there, what I meant was more also, it is a way of writing your code as well, because to write testable code is also important. So you should be somehow isolate your code. For example, you have a function which returns, which gets your name and then returns the time. So this would hello, what is your name, by the way? Cristiana. Hello, Cristiana, it is 7:25. And this function runs, okay? But when I run my tests, my expected result will always change because the time is changing. So when you have a function which always depends on time or other systems, then you can isolate it. You can isolate hello and your name, Christian, but the time could be another function, and you could only test this part of your code. So then you could have a chunk of code, you could do unit testing, but there are some parts, still not easily testable. Maybe you can find other ways, like maybe you can change the time of the system, manipulate that kind of things. And these are by mocking or other dependency injections. Okay, so let's move to integration testing. Do you have a question?
It just going to cover what test-driven development is.
Yeah.
Yeah, it's going to come at the very end. And the goal is to keep you waiting and wondering what it actually is and why it makes sense. And hopefully it will all come together in the very end.
Yeah. So now we move to integration testing. There is already a definition there. This is mostly about you have two components and they are depending on each other. So how could it be this possible dependencies? You already see it, but maybe rather than this database, file system, web services, and third-party APIs, what could you imagine? Or why do you think they are dependencies? Anyone wants to say something about it? Yeah?
Maybe the database is complex. You have the dependencies of one part, I don't know, orders, and the other part is animals. One is more, one is less. And they depend, of course, on each other. They can belong to each other, but...
True. For example, as I already mentioned about, what is your name? Kristen. Okay.
Now that is sketchy. Okay?
That's not random at all.
Is there anybody who is named Kristen in the class? Please raise your hands. I'm just kidding.
Okay. Okay, so let's talk about our function. If we would get this name from the database and think that at some certain places, maybe we don't have any Kristen in the database, or maybe we have two Kristens at the same time, or maybe more. So database is not in the end so much if it's a live system which is always changing, and if you are trying to, for example, I want to fetch all the Christians from the database and I want to get the number of it. This is an ongoing process. There can be new users all the time, and it can be 5 today, tomorrow it can be 10, it can increase. So it's not so easy to keep an expected result on that, right? So that's true on that. Or for example, third-party APIs. As I mentioned before, weather API. Today it's 30 degrees, tomorrow it's not 30 degrees, actually it's 10 degrees or something. And it changes all the time, but you want to write your test to assume that when it's 10 degrees, say, it's a cold day. When it's a warm day, say, it's sunny. So your function behaves like this, but you want to make sure that this dependency doesn't affect your tests, okay? So let's check the example quickly. Not quickly, slowly. So, this synonym, maybe I can mention about you see in the second line, there is synonym. That's a package as well that helps you to mock your dependencies. So, for example, maybe there is a server somewhere that you get the user's information, but we are not sure if there will be a Maria or not. But we want to do something. We want to test our function, Hello Maria function. So for that, we want to act like there is a Maria in the server response. So there, server, we create a fake server to mock it, and then we responded with this function, and then we can check and do some other functionalities or check our functions based on this. Is this clear? Let's talk about mock a bit. Like, what do you think when you hear the word mocking? Fake. Yeah, like it's not real, but it pretends that it is like a server in this case, and then it replies. So this is really good because sometimes maybe the server is down, or when you don't have the data there, or like you can have a test server and then maybe the test server has lots of changes all the time. So for removing the dependency, this is a good approach. For example, what I could say, when you are having a mobile application and you write your tests, what I do actually is like I have scooters, but sometimes the scooters are not connected because the scooter can be connected when you go and physically turn it on, right? So I have a simulator which is simulating the scooter, but it's not real. It's mocking. And then when I send a command to this scooter, I can mock the reply of it. It's not an actual server there. I think I'm making it a bit complicated, but yeah, integration testing is most of the time you have dependencies, but you don't want to test that dependency. You want to test this function. You don't care about this part, the other part. So you take it as a fixed fake information or mocking, and you test this functionality there. But you can also test this part in another way. Is this clear?
I mean, if you go back to the weather example, again, if we're depending on a third-party weather service right now, if you want to test our code that displays a very good sunny animation of a sea or something in winter, we cannot do that because the third-party service will always return like below 0 degrees or something.
We have to wait until summer.
Yeah, we have to wait until summer to make sure that our code can display a sunny weather and a sea, right? Obviously, what you do there is you change the actual dependency on the server with a mock that returns that the weather is like 30 degrees, so that your developers can make sure when they implement this animation of surfing people in the sea, it's actually working. Again, you can never 100% be sure this will work with a real server, but at least you make a bold claim and you say, if the third-party server or weather service can get me a 30 degrees weather, this is what I'm going to display, and it's displaying correctly, right? At least you have confidence there. And if you don't use a mock, again, all winter, you can only check for snowing animations and never for surfing animations. And that's why you have to mock external dependencies which you don't control the output of. Like you cannot control weather. If you can, let me know, because we need it in Berlin right now.
Okay, so let's move to end-to-end testing. So anyone can say anything about it? Like, what does end-to-end, sounds like? How does it sound?
Front end to back end?
Yeah, it is end to end. That's true.
From front end to back end.
Yeah, that's true. Like
It's
actually,
you have to kind of test
Mhm.
the communication between content and backend.
Yeah.
Right?
it can be front end to back end to back end, middleware to back end. That's true. There should be.
External server as well?
Yeah, it can be. So it's, I mean, if you are having different servers
Yeah.
that you.
Different components of the system.
Yeah, definitely. So, for example, when we think about last week, what we did there was we were creating our endpoints, right? Like creating a person, creating an event. We were storing them in MongoDB. Do you remember those things? Yeah, so like when we were doing all these things, we were going to the front end, the browser, and then we were writing Axios commands. So in a way, we were actually testing what we did. Is it really working? I'm calling it, and do I really create a person or an event? So that's correct. In this case, everything is real. You don't mock anything. You have two systems, as also before mentioned. You have a big pile of code
That you don't want to touch.
Yeah.
That some old developer wrote, 3 years before you, and you have to make sure that it's running. And it's just, it gives you nightmares. Try to read the code of that whole chain. And what you do is you kind of treat it like a wild animal. You prod it with sticks and give it some input. And it does whatever it does. It connects to databases, it connects to third-party services, it connects to other servers, other applications, mobile applications, whatever. And at the end of 2 days, you get a response. And you're just satisfied with it because the amount of time you would spend going into that function and that huge piece of code would be much more dangerous for you. So you're just prodding it with sticks from far away and see if it squeaks or screams.
Yeah, like when we come back to the point of like creating an event, like the meetup that we did last week. So we don't know what's going on there. What we care is like, I am calling this endpoint to create a meetup, and in the end it gives me a meetup. And what I do is like I do this call and then I check the result. And if it is created, I say, okay, my endpoint is working. So here, the example is what I just mentioned. I say I will create a person with this information, and then I do the call, and the call is done to a real endpoint. There is no mocking. And after creating this person, I check, because this response of this endpoint gives me the created person. Then I check. Yeah.
Sorry, it's just I'm wondering what if the response doesn't contain any content?
Yeah. Then
How do you then know?
You just check the return code, like the status code.
Yeah.
It has to give you something back.
Or what you could do is, beside that, you can also maybe do another call to fetch if the user is already there.
Okay.
So, it's a common approach to not to return the created person because it's a big file of code again, or like JSON file, and you can just return the ID of the person. And with that ID, you can call again, make another call to get the details of this user. Okay.
Thank you.
So yeah, there we can see like what we could do is we check the status of the response. 200 is the server status. It means that like your service call was successful. Do you know what is 500? Have you ever seen when you open a website 500 code?
Yes.
Good.
The dreaded internal server error. Yeah.
Mm-hmm. Do you know what is 404. Yeah, like everybody knows. Good.
Which one is the teapot? I've heard of this teapot.
218?
Okay.
Thank you.
Good. I didn't know it. But yeah, like in general, you said something?
Teapot. I'm a teapot.
It's a joke.
Yeah. Yeah. That I think part actually gives more context. Yeah.
Yeah, like 200 is
480.
okay.
Yeah.
You look okay. In the end, like what is important is if you expect your server to work right, of course you should check if the status of the response is 200, because 200 means success. But it could be the case that like you delete the person and you try to reach again to the person. In that case, you would expect to see 400s because you can't reach it. Or maybe like how you define your code, it could be different errors, but it shouldn't return 200 maybe because there is no user anymore. So yeah, let's move. So when it comes to the end-to-end testing, we say this is creating a new person, but it's sometimes good to test it. Like, you know, how do you decide what to test and in which form? For example, we have our example code from last week. What we do is, like, for example, the scenario is we expect a user to be able to create to attend a meetup, right? We wrote this functionality. A user, a person, can attend to a meetup. And how can I test it? I would create an event, I would create a user, and then I would attend, like the user would attend to the meetup, and then I would check if the meetup has this attendee. Or I would check if the user has this event. How I wrote my code, based on that, I can check one of these two things. So this would be, actually, when you think about it, this is how your code works. It's the functionality of your code, right? What we call this is like the user stories or user acceptance criteria. So as a user, I expect to be able to attend to a meetup. Do you want to add something on this?
I don't know, but I can definitely talk a lot about this. This is extremely important for every web project or every software project, because these directly map to user stories that the project managers or product managers are coming up with. You know, a user should be able to attend an event. And normally people manually test this flow. Like, I create a user, I create a meetup after every build, and I check if I can log in and attend that meetup, right? The best way, though, to make sure that you 100% complete the requirements for that task, for that user story, is automated through user acceptance testing. And the product manager will define the boundaries, the conditions. You know, the meetup should be new, there should be enough empty spaces, because, you know, you can set a higher limit of participants in a meetup. You can say, we only have places for 20 people, and if a person wants to attend as the 21st person, then they have to be in the waiting list, right? They cannot attend the meetup. And, you know, all of these things should be laid out by someone else, hopefully, other than you. And then the best way to get rid of this, to be done with this task once and for all, is to write an automated user acceptance test for this, which, you know, where you basically apply all of these conditions and then check for all of these conditions. You know, create a meetup with 0 people on the attendee list so that you make sure that a person can attend that, and create a meetup that's full of attendees, and so you can check that there is a waiting list, and then a person can be registered up for that waiting list. And not a lot of companies automate these things, but if you do, then you save a lot of time, a lot of headaches, and a lot of frustration also for your clients or your customers as well. Because you make sure that, hey, there are robots after every change in our code base that are going through the whole scenarios of our application and making sure that the application is safe and sound. And if you can have a test coverage, and that's something we're going to talk next, if you can get a test coverage of 100% with user acceptance tests, then in fact you don't need manual quality assurance or manual testing.
Mhm.
And
I just wanted to ask you, when you were testing the mobile app, did you have an Excel sheet that you can check? So it's actually the same thing. These are the scenarios. Like, what kind of scenarios you had, if you remember one that you can share with us?
I was responsible for testing electronic dictionaries. So there was, for example, two directions, English to German, German to English. And the user could switch these directions, enter different words, and check translations, switch translation from the article, and so on and so on. Many things, basically.
do you remember how many times you executed that test? You know, let's say one scenario.
One scenario. Many times on different devices, we were responsible for the range of devices, the most popular.
Yeah. And you basically ran the same scenario over and over again manually, right?
Basically, yes, unfortunately. That was really boring. It was, I wouldn't recommend the job to anyone.
Yeah.
Yes, it's actually very tough for QA engineers, but it's also very demotivating. Okay, this is why, in fact, when you open up App Store on your phones, 90% of the updates are bug fixes, because we hate writing code, but we hate testing it more, and therefore, you know, regardless of how many QA engineers you have, even like for Facebook, you always have those bug fixing updates. Like, don't ever give them to me. Like, just batch them together for a year, like 300 different updates to the app, because it's frustrating to be downloading them all the time, because somebody just missed a bug, and it's just normal to do so, because this job is very dreadful to do manually. That's why we have automated testing, and that's why this is really important. So you just write a script that goes through all the steps, and machines run it for you automatically on multiple devices even. Like, you can have real phones that are going to execute your scripts, that are clicking stuff on the UI, or are just executing some API calls in order and checking the inputs and the outputs, so that no real human ever has to run those tests manually ever again. And then we save you, and you can become software engineers. Maybe I need a parenthesis here, because this is a personal topic for me that I hate the most in the industry. Unfortunately, even though they have graduated from CS programs, some women, by their managers, some women engineers, by their software engineering managers, are pushed to QA. I'm not sure if there is anybody in the crowd who had this experience, but some managers say, oh, you become a QA engineer. You test our code. Like, we're going to write the code. You cannot write the code yourself. We're going to do that as men. And as a woman, you're going to test our code. And this is something that I hate in the industry, and that's why we're actually here, to change this. Because, again, this is not a good job. It's very boring to be able to test things manually. And if we did this last year, there was one QA engineer who became a software engineer right after this course. If we are able to replicate it this year again, it will be awesome. Because the goal is to do more fulfilling jobs, right? Everybody can write software. And our goal is to eliminate this need of manual testing. This is why it's important to push for automated testing in the companies and eliminate the QA role 100%, because we are underutilizing those people,
And those women are unfortunately, pushed out of the engineering cycle, and just test my code. That's a horrible thing to do, and that's why even if you are not QA engineers, even if you are software engineers, if you have QA teams in your companies, it's good to have this mentality of, hey, we're gonna do automated testing all the time, and we're not gonna have a QA department, quality assurance department, that are, who knows why, magically comprised of mostly of women. I've been in a lot of engineering organizations, 90% of them are women. And this is a huge discrimination coming from men. And we have to change this together. This is why this lecture is very, very important, because you're not only learning how you should test your code or why you should test your code, but this is also a transformation of this industry that we need. Please.
Might there be situations where the QA testing is really necessary? Because I'm thinking of the gaming industry. You have to stress test the engines, otherwise, as soon as you release it, everybody goes on, bam.
We also automate that as well. You can have hundreds of different servers that are randomly sending input, like gamepad input, to your game, connecting to it, and then testing your endpoints and load. It's less expensive than hiring real humans to do so. But it's just a lot of effort on the engineering team. That's why they don't want to do it. It's better to hire a QA team who are creating automated tests by writing software and not doing stuff manually. And I think you can relate to that as a test engineer.
Yeah, well, but in my company, actually, we have to do this automation testing, and the developers are not doing anything with the testing. They're just writing this integration testing, and the rest of the tests we're doing. I'm doing all of the tests and also this automation one.
Mm-hmm.
And also the last test, the load testing as well. So it's also really cool.
Yeah, as long as they're automated, it's fine. That's a real job where you write software to do so. I would love to have developers do that, because it's like eating dinner and not cleaning up after yourself, right? Mm-hmm. You ate all the good things, perfect. Now it's your turn to clean up and clean the dishes. Mm-hmm. And surprisingly, men don't do that. This is a very recurring pattern. They just leave the table like that. And it's just not okay to do so.
And in my company, all the trades are women.
Yeah.
Yeah.
Of course,
there
that's...
There is no...
In my experience as well, I had several QA engineers in the past. I had only one male person in that group. All of the others were female at all times. And this is just very stupid. We have to change this. This is why I'm trying to raise an awareness in you about this topic. It's not only about learning how to do code, but also causing a change in human behavior and in the industry, hopefully. Sorry for hijacking it again.
Okay. No,
but this was important.
Really good, yeah. But when it comes to writing tests, sometimes there is an approach of some people write the code, and for UA testing, it's also recommended not to write the UI test. You don't have to, actually, because it's more about the UI. So you have to act like a user, not like a developer. But for unit tests, integration tests, end-to-end tests, it's good to write it yourself as a developer, because then you can find out another case and you can change your code based on that. So we came to UI tests now. UI, it's user interface, and this is mostly done for front-end and mobile applications. This is not manual. So for different programming languages, there are different tools to set up this. So for example, it could be Selenium or Appium, or for Xcode. Xcode provides the UI test recording system. So you just need to click on the screen, and then it already finds the elements and creates a scenario based on that. So you start recording and you do the moves on the screen. So then like you log in and then you don't have to log in each time yourself. The code repeats this same steps in different devices or in the future for the chains as well. So that's much better than, of course, manual testing. Regression testing is like what you mentioned before, actually, because you mentioned that like when I change something, it shouldn't affect, and I should be able to find out if something else is affected. So regression means, for example, you have a bug, and then you fix that. It just touches one area, as I already mentioned. So you have regression testing, which tests all over all the functionalities in the end again, so that, you know, if it affected something else, and you would know it before the user finds out, because you wouldn't even push this code to live system before passing this test.
So the idea is, let's say you are again implementing Meetup, and there's an attendance functionality where people can attend to meetups. And there was an area there, for some reason, some certain percentage of the people wouldn't be able to attend meetups. And that was a bug in the production system, so you fixed it, and you pushed it live. And now there's a bug fix for that, and there's also a test for that, right? And this test makes sure that that bug will not happen again in the future. And if for any reason it happens again, then that's a regression. You know, like, you had a bug, you fixed it, 2 years later, or maybe like 2 months later, that bug happens again. That's a regression. And what you do is basically you go back to your previous bug fixes. Hopefully, each bug fix comes with a test to ensure that bug is fixed. But most of the time it doesn't, because developers are lazy. They just fix a bug and they don't write the test for that bug fix. And what happens is that there are a lot of regressions. Like, the same bug happens over and over and over again. Have you ever run into a scenario like that? Like there was...
Many times.
Yeah.
Of course.
Because like...
Before every release.
Yeah. What happens is, you as a tester, you find a bug, ask the developer to solve that bug. The developer solves that bug and is now confident that it's actually working. Now you find another bug that's just unlocked by the first fix. You go back to the developer and ask them to fix it again. They fix the second bug, but it reintroduces the first bug. That's a regression. Because like they didn't have an automated way of testing if the first bug was fixed forever. And just because they didn't, now it's more work for everybody again. Now they have to go back for a third time back into the same code base and reapply, or with little modifications, fix the first bug again. It's very stupid. I can see some faces and some eyes who don't believe me that, you know, how stupid can people be to lead to this scenario? But we are. Because again, we hate writing code. And we hate testing them. We don't test it enough, and it leads to a lot of regressions and a lot of reoccurring bugs all the time. And it's, you know, if you do proper regression testing, automated regression testing, for every bug fix, if you write a test, you almost 100% make sure those bugs will not happen again. Of course, you can never be sure, but at least, yeah, please.
I have a question, but the integration testing or between developers is just done when somebody says to you, okay, this area is like a bit buggy, this functionality, just write an integration test. Otherwise, the developer just develops it and then leaves it like this, or how does it happen? Because I don't know still that this side.
The regression testing one?
No, the integration ones. Like for the other functionality, as far as I know, that they develop, they don't write a test. It's just, I mean, at least it's my experience. It's just when there is a warning from the project manager, for example, like this, the customer has told us, okay, it's like a very buggy function. You have to like kind of assure it. So they start writing unit tests for this. Otherwise, they're not writing like unit tests. They just develop and give it verification.
I think the next slide is about this, and we're gonna get there.
It's because the numbers are acting like God in the team. That's why.
Oh.
Yeah. Very
Okay.
stupid people.
But it's mostly like this. So
Yeah.
nobody
Yeah.
says anything.
You have a question?
Yeah, I heard about regression testing.
Uh-huh.
That it's, I thought it was was something visual because there was a situation where we deployed something to an environment, and then the developer said, "Well, can you make a quick regression test?" I was like, "What does it mean?" And then he just said, he responded and said, like, "Yeah, just check on the page if everything looks fine."
Yeah.
So I
Well, technically it means go back to the previous list of bug fixes and make sure those bugs are not reoccurring here. But obviously, we are banning the words, and nobody is actually using regression tests for what they are. And they just, it's just another fancy word to sound like it's not the boring job of testing everything again. They just say, oh, do a regression testing. But it basically means make sure nothing we fixed previously are reappearing. Manually. Did you have to do that? That regression test?
No, yeah, just like checking in the browser.
Yeah. So it can happen everywhere. It can happen in the UI, it can happen in the backend.
It sounds like he didn't know what it meant.
Yeah.
Not listening. Yeah.
I was trying to be polite about it. But yeah, most of the definitions of these things are not clear to software engineers, especially if they are math. Since they don't care about testing, at all, they never even take the time to properly understand and learn what the words mean. They're like, yeah, we're doing end-to-end tests. Sorry, this topic is important. So yeah, this last slide, the one what you were waiting for a very long time, test-driven development. Let's talk about that. Like, we kind of mapped out a lot of problems, a lot of issues with testing, and we mapped out different ways of testing, right? Please tell me what test-driven development would mean in this case.
As far as my experience, test-driven development means like tester is included in the beginning of the development process, not we are testing after the development, but we are testing as we receive as a tester the requirements from the product owner, and then we write our test cases, and then the developer also knows what type of functionality he should implement, and then he kind of behaves accordingly.
Kind of behaves, right?
Yeah.
It's kind of a leash on the developers. Yeah.
We don't enter this subject like
We don't use
relations between developers and testing.
Yeah. Any other definition?
No, I think it's almost the same, but in our company we have new developers who work like that, and they create the tests first, and then they write the code for it.
Yeah.
So and then they can, and then they also test the code that they have just written, if it passes or fails.
Yeah. So, any person who heard test-driven development for the first time, please raise your hands. Please. Could you tell me what does this sound like?
Like how they explain it sounds nice. I don't know.
Okay.
Like, it makes sense, but
Like if you put it within perspective of what we talked so far, about the problems, about regression testing, for example, and about different types of testing. Does it sound like everybody should do test-driven development?
probably not. I mean, it sounds slow in a way.
Slow?
Maybe slow for those who are not experienced with testing.
Yes.
So it's, I don't know, probably not.
This is a very good point. There are a lot of academic researches being done about
Like whether test-driven development slows you down or not.
because obviously developers wouldn't like to do that. What test-driven development is, basically you write the tests first. Before writing the function, before writing the sum function, you write the name of the function, sum, and you write that 1 and 2 as the arguments, and you expect it to amount to 3, right? However, there is no function yet, so it will throw an error and say, hey, this function is not implemented. So you then go and implement the function, and then it's going to say, hey, this function doesn't return anything. And then you go back and implement, hey, a plus b, and then it says, it passed. This is correct. This is a good implementation right now. And then you're going to pass in strings and try to have a proper output of it, and it's going to break again because you didn't handle strings with like addition with numbers. So it's always being a step ahead of yourself. Write the test, see that it breaks, and then go back and fix that. And by this approach, you do a lot of iterations on your function, but you also make sure that you have 100% test coverage, that you test every single scenario that comes to your mind, and you, before finishing your function, or as you put the last semicolon to your function, you make sure that it's 100% correct, which is a huge thing to achieve.
Yeah, but this brings the question that do you actually write the test for each function then? Like each and each and each? Because if you write a test for like maybe a chunk of functions and then you have to fill everything up, it kind of takes a long way until you actually have the correct result from the test. So I don't know if you really just...
That's a great discussion. Please.
You have to do it anyway. We're discussing whether we should write the test first or not.
Yeah, this is a good point. So there will be bugs in every piece of code and in every line. So you have to make sure that there are no bugs. And in order to do that, you have to write tests. So if you don't write them first, you're going to have to write them in the end anyway, or somebody will have to write them. Obviously, with this turnover rate in startups, you're going to be at another company when there's a bug in the code that you wrote, so that you won't have to write tests. But the idea is some people will suffer. So for the collective sanity, it's best to write the tests first and then implement the code and make sure that you have 100% coverage at least of all your code base. And it takes a lot of time. Yes, that's true. However, at the end of the day or the year, let's say, it saves you from the bugs as well. So test-driven development, 1 hour of test-driven development saves up to 33 hours of bug fixing. 1 hour of test-driven development saves up to 33 hours of bug fixing. Please.
And what is the relation of developing and bug fixing without test-driven development?
Yeah, I don't know. But yeah, in fact, what we do mostly throughout our days are that we're hunting for bugs. Even when we're writing code, we think a piece of code will work, and then it doesn't. And then you write it in like 10 minutes, and then you spend the next 2 hours figuring out why it doesn't work. Please.
It was a line question, but so what about the debugging you were talking about? Is it not the stage where you can more quickly and just check if the code is working?
So yeah, even with that, that's included in 33 hours. So 33 hours, somebody will have to find the bug. Somebody will have to report the bug. Somebody will have to replicate the bug and make sure that's a proper bug. Somebody will have to put it on the list of to-do items of the engineering team. And then an engineer will go in and try to debug it. We'll spend hours in debugging it, because obviously these systems that we have developed so far are very basic, very simple. And in a real-life system where you have 200 different classes and 5,000 interactions between them, you're going to spend days and days debugging a single piece of code. And then in the end, you're going to make a patch for it and a fix for it, and then you're going to release it, and then the infrastructure engineers are going to deploy the code to production, and then QA engineers will test it again before and after deployment and make sure that the bug is fixed. This is also included in the time. So yeah, test-driven development looks like you're spending a lot of time initially on the tests, but then your mind is free. Basically, it just works. And you can, as a developer, you can be confident that whatever you write will not break anything as far as our collective knowledge goes. It will not break the current operation of our software. Because if it breaks, the tests will break. And you can make sure that whenever you're introducing new functionality or changing functionality, that if the tests are green, if they are passing, more or less everything is okay. Please.
Can you implement every test with test-driven development, or is it just unit tests, or implement everything, like also visual testing?
Not UI tests, I think, but unit tests definitely. And for some cases integration as well, but you first have to create the endpoint maybe so that you can, but maybe you would write your test and then you would have some rules which you will build top of it. For example, you can say, okay, you know, as Armand mentioned, the meetup, everybody can attend. And then you can come up with a functionality of a limit to a meetup. So you can say, okay, I have a new feature. Every event has to have a capacity. And then you start implementing it and with the test first. And then you write more functions around it. And then, you know, the endpoint would respond like this event is full. Okay, so this is what we...
Let's discuss in the break.
This is what we had so far. I think we have the break in 20 minutes, so let's start writing something at least.
It's actually...
Now? No. Really?
Yeah.
When is it?
She was motivated to.
It's 8:10.
Oh, yeah, okay.
It should be at
Okay,
8:15.
then, yeah. Then on the next half, we are fully hands-on.
So one last thing before we go for a break is the coverage. We barely mentioned what it is. So we have metrics to track, at least to give us a number of confidence, right? What we can have is we can check if we are testing all the if and else cases in our code. We're testing all the lines in our code, and you know, because if there's a line of code and if you write tests for it, you kind of make sure that you cover that line. That's called line coverage, and it's given in percentage. So let's say you have 100 lines of code in your program, and you write tests. You know, let's say you wrote 400 tests for that, and you cover 95 lines, and there are 5 lines that you couldn't cover. You have line coverage of 95 because you have 95 lines of covered code versus 100 lines of the whole code base, right? This gives you a rough idea of confidence, which means, yeah, 95% of your code is kind of probably bug-free, and the rest you should take into account. But unfortunately, it doesn't tell you how important or how hard the bugs will be in that 5%. You know, those 5 lines could be the most important 5 lines in your code base. And as developers, you have to be careful to optimize for these things. Obviously, nobody has infinite time. And even though test-driven development saves you a lot of time, it's not saving your time. It's saving other people's time, plus, you know, maybe your colleagues or your time as well. So we have to optimize what kind of tests we write to increase the line coverage. It's always a dream to have 100% code coverage, to have 100% line coverage. However, we cannot go there, we cannot do it because it also takes an infinite amount of time to achieve that 100%. So you have to be smart about what lines you want to cover, and while trying to get closer to 100%, always make sure the most important lines are covered first with the least amount of time invested. Does it make sense? Please.
So like starting as a junior developer, so like, you know, we are here, so you have so much experience. So what would be your suggestion? Just right from the beginning, having the habit of test-driven coding, or
Yes, that would be the best. That would be perfect. But honestly, I don't know one will do that. That's why in your homeworks, you're going to be asked to write tests. Hopefully, you're going to do test-driven development for the rest of your projects. But honestly, I don't expect it.
I did not send this with 95% of this line coverage. How do you cover the lines? Can you explain it? Like, you just rating these lines for every functionality test, or what do you mean with that?
So, for example, how many lines are there in this code? This is a test, obviously. This is not your function.
Yeah.
But let's say this is your function.
Yeah.
There are like 7 lines, right?
Yeah.
Then you write a test that checks if you could create this person.
Yeah.
Now, is that a piece of logic? Not really. As long as when you call this function, it doesn't crash. And when you write a test for this line, which is actually doing some action, it's covered already. Or like in summation, when you have a plus b, if you write anything that calls that function, because it's a single line function, right, that line will be covered, basically. So you can write one single line to cover 100 different lines, because that's a long function, and you don't have any branches in it, like if, else, switch case statements. But you can also write tens of lines for a single line of code. Obviously, they won't increase your line coverage, because we are checking for the coverage of unique lines, individual lines. Does that kind of make sense?
I can show it when we are writing
Yeah.
the demo, like the code as well.
But are we gonna write a demo? I mean, as well as both for the integration testing and also for other test types?
Today we will have unit tests and end-to-end tests. Unit tests will be a project that we start from zero. We will have some functions and write unit tests for them. End-to-end will be for your projects, but like we will, not for your projects actually, for the meetup project that we started last week. And then you can write end-to-end tests, or also if you have some functionalities in your project, you can also have unit tests to cover that as well after today.
And obviously the goal of the homework will be to get 100% line coverage and branch coverage for your code. And last year, 1 or 2 people were able to do that. They were like writing tests like crazy. And hopefully some of you also will be that bright, shining person to achieve 100% green light everywhere.
Yeah, okay,
So let's take a break and come back in like 15 minutes.
But I want to say one more thing for test-driven development. You don't have to pick one of these approaches, like either with it or not. You can also use it like for one feature that you are developing. You can say, okay, now I will do test-driven development. But for the rest of your code, you don't have to go on doing it. So you can just think, okay, this is a good functionality that I'm writing here. It could be validation functions or some mathematical functions, or I don't know. Then you can say, okay, I will try it out. And just for this functionality, I will write the test first and then the code. So it doesn't necessarily have to be that you have to do it all the time like that. So, but now we can start. Everyone should, open their terminals, command line. If we are all there, and where is the people? Okay, so
there are some TAs here.
Yeah, I think that's the time. So whenever you need to, you have a problem, or like when you need to ask some question, or if you couldn't follow up, you can always ask our lovely helpers, guides.
Yeah, sorry.
Okay, perfect. So you can just create a folder or whatever. Like we will create our project now with npm init. Everybody knows this, right?
Enter that CD into the folder first.
Oh yeah, first. Okay. And then we just write npm init.
So first create a folder called whatever you like. We call it testing. Then enter that folder. We do it by saying cd testing.
Outside of our repository.
Yes, outside of your repository.
Yeah.
For example, in desktop.
This is a standalone project that we will work.
But is that okay to npm init and
you can also do it like that.
You post it in the file, but you post it in the GitHub. So like, it is fine to do that with that file.
No. Create an empty folder from scratch.
You can help maybe.
Create an empty folder from scratch and enter that folder. Make sure it's empty, and then run npm init.
Yeah.
And raise your hands if you need help. We're all here to help you out, to get you started. There is no reason to panic.
Okay, everyone is aligned or... Do you need help?
No.
Okay.
And obviously, if you don't need help, maybe you can offer help to others.
Do you need help? Okay, so I just... Okay, then we just press enter, okay? We are keeping it as simple and with the same name with the folder. Just enter, enter.
So this is what you see when you run npm init. Just hit enter until it lets you free. Because like it's asking like 10 questions and then it gets you back to the console. So you can do new commands.
Okay, so if you check this folder, you will just see a package.json, nothing else, okay?
Cool. Now, the next step, because we're going to do test-driven development, right? The next step, or the first step, is to have an infrastructure where you can test your code. Before writing any piece of code, we make sure we have tests. That's why we start with the testing infrastructure. We're going to introduce a new library called Ava, which is a very, very easy to use futuristic test runner for JavaScript. Hence the name Ava. And you're going to install it by typing npm I or npm install -- save dev Ava.
Can everybody see it, or should I switch to here? I can also do it like this.
Yeah, npm I save dev Ava. Can anybody tell me what save dev is?
You save it for your development environment.
Yeah, you save it for your development environment. What does that actually mean?
Well, it means you probably don't want your test code and everything to go out through to your production, so to speak, when it's live on the server.
Exactly. So Ava is a test runner. In production, we don't run tests. There's a t-shirt, if you have seen the meme, I don't test my code, but when I do it in production. There's a meme like that. We don't do that, obviously. We test our code in testing or in development, or even before we start development.
Or users can test.
Sorry? Well, there are some tests that happen in production, but only after you have all of these in the development and test environment. So we save this Ava as a development dependency, because all the developers should be able to write tests and should be able to execute tests, right? But in the production environment, in the live environment, you are already through all of these stages and you're not supposed to execute any tests. Therefore, you don't have to have this dependency of a test runner in your production environment, which is a cost optimization. Because obviously this is like a huge library, it's still installing. If you run it, hopefully it will install faster in your machines. But it's a heavy library, it's a heavy piece of code. And you don't want this in your production, your real environment, because you're not gonna use it, hopefully. Does it make sense? Cool. Save dev is what we use for development dependencies again. And
yeah, we can also mention that Ava is used for parallel testing. So when you have multiple tests, it can run in parallel, so that you don't have to have tests running one by one. If you can isolate your tests, that's the best, so that maybe you have person tests and meetup tests. So these two tests can run concurrently.
In parallel.
Yeah.
Yes, we're gonna get to that part in a bit, but look at the number here. Just installing Ava, one single library installed 592 packages from 199 contributors. So like 200 different people pushed code to Ava to make it happen. This is a test runner. Like the only purpose of this library is to run the tests that you write. 200 people worked on that. This is the power of open source, right? It would be impossible for a single person to do any of these. Like 200 people put in their efforts and came up with a library so that you can do tests. And they have like 592 different packages of Node.js libraries. They're also Node.js projects. So this thing is huge, and it's also very serious. We take it very seriously. And that's also why we don't want it in production. Like 600 packages, in addition to my own, when I push my code to production, is useless. And therefore, we only save it for the development environment. Now,
Okay.
yeah, maybe.
So now we will start writing our tests. As we mentioned before, we didn't write any code yet, but we will first write our tests. So everybody opens I think everybody opened their projects with Visual Studio Code.
Yeah.
And then
Please open the folder in Visual Studio Code. I think you do that, like after opening Visual Studio Code, you do that by going to File and Open, and then choose the folder, so that in one hand you have the files like this, node modules, package.lock.json and package.json, and in one hand you have the editor. Again, if you need help, raise your hands and one of the TAs will come over and help you.
Okay, so here I can do it manually or with the command line. We create our test folder, and in the test folder we create our first test.
So our source code will go under a folder called source code, and our tests will go under another folder called tests.
And since we we are working on unit testing now, we will test the sum function, but the function doesn't even exist yet. But first we write our tests. And what we do here is to this maybe.
Can everybody read the screen? No?
The color contrast is super
Yeah.
What should I
Okay.
do?
Yeah, maybe we should change the color scheme to white. Color theme to white. Yeah. Is it better? A little bit better, right? Okay. So beforehand,
Is this better or?
yeah. Beforehand, what we did was we were doing const person equals require person, right? That is one way of importing modules. The other way of importing modules is by using the import keyword. However, this is not going to work in your actual source files. This is a new syntax that Ava supports because it's a new JavaScript standard, but it's not supported by default in Node.js environments. So we only use it in our. We only use it. No, you just. It's addition.js.
Here.
Okay, so import format, import syntax only works in your test files for now. So in your actual code, you're still gonna keep doing require syntax, but here we use import test from Ava, which is a library that we install for running tests. No, I mean that looks like the case because again, it is the new syntax that we can use in the front end because we're using tools called transpilers, which are converting our new syntax to the old syntax. You can also use transpilers in the backend as well, and you can keep writing import statements, but it doesn't make any sense. So we just use require.
in the front end, in order to use any kind of modules, you need a transpiler anyway. That's why it's okay to use the newer syntax. But in the backend, we have modules by default, so we don't introduce transpilers, which are an additional 2,000 packages in your development environment, so nobody needs more packages while they're developing code. That's why we keep using the previous syntax. But since Ava already introduced these 600 packages and it supports the new syntax, we write our code in the new syntax with importing import function. Please.
Okay, so as we see that here, first we have to give a name to the test. For example, it could be create a person, attend to an event. For this one, like first we will try to see that like this test is passing. This is the initial step that we do now. So we will just have the name as automatic pass, but you can name it as much as user-friendly or developer-friendly as you can, so that when you check it, then you understand what this test is doing. So it's really important, again, as always, the wordings for this. And we will just... What did you ask?
I don't know. The comma, but okay.
So you can see lots of things here, like what lots of different functions. Now we will just try the past method. We saved it. But do you think it will work or not? Yes? Okay, so I just write npm test or run test, and I got an error. It says no test specified, exit. Okay. So the reason for it is that like package.json, when the Ava is first installed, writes this. When it's not, when we didn't define it. So you have to write Ava. So whenever you run npm run test, it knows that it should run Ava. Is this clear?
So package.json by default has a test script that just gives you an error and does nothing else. You have to tell package.json and Node.js that I write my tests with Ava, and whenever you need to run the tests, call Ava. And for that, we go back to package.json and update the test script.
So it was like this, and then we changed it to Ava. And the result was one passed. So there are some more, because we only had one test, which was the automatic pass.
I'm going to run the screen because the other one, switching back, it doesn't work on the screen.
Okay. But here it's hard to see as well. Anyways.
So that was one test.
What is the, like?
And it passed. Sorry? Oh, yeah.
So we don't have much things here, as you can see. It's just like one test, which just passes.
When we ran npm run test, we actually just saw that Ava is running, and then it said one passed. Now it's not very clear what passed. What does one pass mean? Yeah, it would be really good if we had some more ideas on what this test was doing, you know? And there's a good way to do that. Like, it would be perfect if we could get the contents of the tests and see what it is actually running. Because, like, if we have 200 different tests, we want to know what individual tests did it run. Maybe we're not running the whole, like, every test every single time. So there is a very easy fix for that. You need to update package.json and add -- verbose at the end of Ava. And when you run it, it will tell you the name of the test with a nice green check mark. And what you have is automatic pass, pass. And when you introduce more tests, it will list every single test, one under the other, so that you have a clear idea of what tests you have and which of them passed and which of them failed. Does it make sense? Okay, please add dash dash verbose.
So it just lists the names, all the names of the
Yeah.
tests.
The second command that we're going to introduce is watch. Ava dash dash verbose dash dash watch. And what it does is it saves you from running npm run test or npm test every single time you change your code or you change your tests. It will watch for the file changes in your file system and run the tests automatically, even if when you save that edition.js again. So if you go back to edition.js and just save the file, you will see that it's basically it's going to run the tests again. You don't need to
like this.
you don't need to even change the name of the file or the test, but when you just save it, it's going to run it again. And you know, if you change the name of the test, when you save the file, it's going to run it again, and you're still going to see the green check mark with the new name. This is the way you can do test-driven development. Like if you have to always run all the tests from scratch again by hand manually, it will take you a lot of time. This has to be automatic. So this is checking for the file changes, and whenever you write new piece of code, it's running these tests automatically. Now let's maybe implement already the sum test and see that it's going to fail first, and then we're going to implement the function.
Maybe we can first start with the fail to see that like we fail. It's like pass. So we would see how would it look when a test fails.
Yeah. So test in parentheses fail, and the actual test to run is an automatic failure. We don't have any assertions, we don't check for any results, any output, but we directly fail the test by saying t.fail. This is a good way to have failing tests because the challenge is to get those tests to pass, to run. You try to convert those red crosses to green check marks. And the best way to start is by failing. And that will give you a sense of achievement when you finally implement the proper version of your code, right?
Mm-hmm. And then there's something to fix now. So let's start with the sum function. Is this a question to the class? Okay.
Yeah. So like we have t, function t pass, and function t fail. Is it like is that in the environment test? So like is it that confusing? So like we use the same name of the functions, or it will work? I'm a bit confused about.
It's the Ava. So
no. The line 3 and the line 4. So we have the same t fail, t pass.
Yeah. So this is the syntax of Ava. You have a function called test. The first parameter is the name of the test. The second parameter is the callback function, which takes something called what? No.
Won't be easy to see, but
No. Just go back to the which is a callback function with a single parameter that's t. That is like the God object in Ava. That's like the test object, and it holds a lot of different functions for you to use. Now we introduce two functions on that, fail and pass. These are automatically ending the tests. And the first one, t.pass, is saying this is a green check mark, this is a green passing test. And the second one, tfail, is a method we use for automatically failing the tests. Obviously, when we start to actually build the tests themselves, we're going to use, if you remember from the previous lecture, we're going to use something called t.is. And fail, fails, pass, passes, and is a check for the expected output. We want to check if the output is what we expect. Okay? And we're going to just write it down. So the name of the test is add 3 plus 5. Now we don't want an automatically failing test that doesn't serve anybody, so we just comment it out.
we can also comment the other one. We just have our test for addition function.
So we're going to type T,
Yeah.
fat arrow, so that it's a function. And now we're going to call the method that we have, the sum method, right? Is it correct? Const result equals sum, in parentheses, what? Please raise your hands. Please. Yeah.
3 and 5.
3 and
Good.
5. Yeah.
Perfect.
So this is a test for the sum function that we have, right? Somebody should say no here, because we don't have a sum function yet. Because we're doing test-driven development, we're writing the test first. There's no code yet, right? Do we have a sum function already defined? No. This is something I just made up. I imagined that there is a function out there somewhere that's called sum, and it should take 2 inputs, one number and another number, and it should add those inputs together and give me the result, right? This is called designing the API, and you can read more about this in Google. Before you write the actual code, you first imagine how it should look like, and perfect that, improve that image to the best that you can think, to the best of your imagination, so that it looks as good as possible, as concise as possible. And for the summation, we say, okay, we have a function that takes 2 inputs. It doesn't take an array. It doesn't take an object with input 1 and input 2. It takes 2 different parameters, 2 different options. And we automatically write it. This function doesn't exist. We are now confident this is how it should look like, and this is how it should function like. And then we're going to see, we're going to have a failing test, because the sum function doesn't exist, right? And then we're going to go back and write the sum function.
Okay, so for that, the test is somewhere that we just have our test. So we have to go to our project and create a file. It can be anything, but I say it like a mathematics library. So there can be later more functions inside, but I start with the function of addition or sum. So I just say exports sum, which would be something. What would you write here, which could make something that we have here? So this is the point we come back.
But it's actually already running, and you see it's already failing.
Yeah,
now
here.
We're watching the tests, right? We didn't, because we're not there yet. We're not
Sum
at the
is not
stage where we
defined.
can do an assertion, because we don't have the function yet. Obviously, you could write the assertion right now, but since this is already a failing test, let's first make sure that this is green, and then introduce a new assertion that will fail again, and then fix that.
Let's say that this just returns 0. Like it's a function. It just returns 0. And
what
then
you see is that there's a reference error, that there's an error thrown in the test, and it says sum is not defined in our test. Why is that the case? Because we didn't import sum here. So just a brief recap, what we did, we created a new file called library.js and put in a function there, which we exported, much like we did in our homework in the past. And then we see that sum is not defined in our tests, and we're going back to the addition test, right, and importing that library that we created, which has this sum function inside. And when you finally import and update your test that reads on line 5,
we see that
result equals library.sum 3 and 5, you see again the test failed, and that is
because we didn't write the test yet.
Yeah.
So what we do here is as we talked from the beginning of the class, we say there is an expected value that I expect my code to return, and also the actual result of it. So we already have the result here, and we compare the result with the, as you can see, value and the expected. So value is the result, right? The result that I have here. I call the function, I got a result, that's the value. And I expect this to be what? 8, yeah. Perfect. And we can have a message. So to be able to understand why this function or this test fails or succeeds, I just write output should be 8. And now you just see that my test failed because there is a different unexpected result.
So output should be 8 is a string that we wrote. Okay. However, we have a difference. We were expecting the result to be 8, right? But what we get is practically 0 because that's what our function returns. Here, the library is your piece of code. That, you know, your source code, whatever you created so far, the index.js, the person.js.
You could also, yeah, have it as index.js or addition.js as well.
Of course. And we just called it library because we're going to put more functions there. It's like a library of functions, a library of books.
Unless you import it with the same name, it's imported into the...
Now, again, it's very important that we are all aligned and everybody's at this level. So please raise your hand and I call the TAs.
Okay, so we move to our library. Obviously, now we have to change something so that it returns the expected value, 8. So how would you write this function? Any idea? You say. Okay, I don't know, if you want. Okay, which would be value 1 and value 2. And then? So it's something like this. Perfect.
So it's basically a function that sums 2 values, value 1 and value 2. Right?
And I just save it. And I see that it passed.
As soon as you save the file, the library file, with the updated function definition, the tests run again, and you're going to see that it's passing.
Okay, so when we have the function, we go back to the test to find other cases. So how can I test my function with different variables which could maybe surprise me with the results? Does it make sense? Like you always go and try to test it and find a case, and then you go on to your code to improve your code to fix this problem. It's always like an evolving process. Okay, so here let's add some more tests because this one I know it works for the addition of 3 and 5, but I don't know if it would work for some other numbers. So I will basically copy paste for now with some different functions, variables, like let's say it's 4 and 5.
So we create a new test by copying and pasting the previous one and just changing the name of it and the parameters of it. So previously we were testing 3 and 5. Let's now test 4 and 5 and see if it works. When you save it, what you have it, the tests run automatically again,
And now you see there are two tests passing with two check marks that are like add 3 plus 5, add 4 plus 5, and they all work, right? This is good, but this is not an edge case. If you can add 3 and 5, you probably can add 4 and 5, right? Can we find another set of values that would be an edge case that wouldn't work? In fact,
0.1 plus 0.2.
yeah.
Oh,
In fact, if you remember the very first lecture of the series, I already gave you an example that doesn't work as expected. And that's a new test where we add fractional numbers. So what we do is we copy and paste the second test again to create a new one, a third test. And we're going to change the numbers from 4 and 5 to 0.1 to 0.2. Okay? And we're going to add these two numbers. What do we expect the output to be? 0.3. The output should be 0.3, right? And when you save the file,
no.
you see it doesn't work. And there's a difference. If you
And
scroll
everybody
up,
goes crazy.
yeah, if you scroll up, you see that two tests passed, and the one test failed because output should be 0.3. It failed, and it failed on this line. And we see the difference. We were expecting 0.3. What number we got? 0.300000004. Because JavaScript doesn't know how to add numbers. In fact, fractional numbers. In fact, all numbers are fractional, but some are more fractional than others. And JavaScript cannot add those numbers properly. And now this is basically up to the application developer to fix this or not. Do you want to fix this? Do you want to fix adding fractional numbers that would lead to errors like this? Or do you want to keep it that way? Like, do you care about fractional numbers? Do you care about this exception? That's a decision that you have to take or give. I don't know whatever the proper word is. But the idea is these things depend, and you might want to solve it. You might not want to solve it, right? In this case, do we want to solve it?
I can say that, like, for example, if this sum function will be used for money, I can solve it for fraction two digits, because I can have some cents, but it would be like 1 cent, and 2 digits from after the dot would be enough, right? If I will use this sum function for money, this would be enough. I don't need all these dots after dots, but I just need these 2 digits, because I will use this function for money, because I love money, obviously.
Who doesn't? Yeah.
No, I don't love. I have some other things that I love more. Let's just do it quickly, and
so this has a very nasty solution. It's a very dirty one.
Yeah, but if it's for the money, it works.
Yeah.
And then let's say,
if you implement the fix, you're going to see that the result is, in fact, 0.3. So there is a way to fix it in the very most unintuitive way, by multiplying the numbers by 100 and then dividing the output by 100. Now, this is not a fix for every single addition. It will break again at some extreme edge cases, but you're good unless you hit those edge cases.
Mm-hmm.
And for now, it's okay-ish. Depends.
Okay, so there, I think this is a good example for test-driven development. You make a decision at that moment based on your function, and you say, okay, this is what I need, and I implement it based on that, because I want 0.1 and 0.2 to be 0.3 in the end. So, okay. Then now we are done with the unit test. We will move to end-to-end testing. So for that, let's just go to our repo and clone it if you didn't so far, or just pull the master because we have a new commit. Okay, so you can do npm install again, because I have, like, you have to go to the folder of week 6 testing, and you have to write npm install so that you get Ava and some other packages that we install. But I want to mention about them a bit, actually. So you will see that we don't have just Ava, but we also have NMyC, which is for showing you the code coverage, as we mentioned before in the previous session. And also we have the super test for the requests that we do to the service. Okay. So if we just run npm run test, 6 testing, npm run test.
So do npm install and then npm run test, and hopefully you're going to see this output.
So if everyone is done, maybe I can also mention about this whole project, what I did, what is different than last week. So models are the same. I didn't change anything. It's like the ones we had last week. And for services, I didn't change anything again. They are all the same. I just changed a few, like I added a few more endpoints, because I saw that it's not easy to test this. So when you write test, this is something happens to you if you write it afterwards. So this is good. We had the test-driven approach. Now we are writing the test later. And I saw that person all was returning a render page. So this is not like a REST API response, because a REST API response should return the people JSON, right? Not the view. So this one renders people. So this is an endpoint of a view, actually.
So it basically gives you an HTML. Obviously, you can also test the HTML output of a web page, but that's another type of testing which you may not want to do at all times. What you want to do at all times is to test the output of your APIs. Then that it's giving you the right JSON, that it's giving you the right objects with the right names and properties in it, right?
So actually, we have a word called refactor. Did you hear about this before? Maybe you already heard. So refactor means like to make your code each time better and better. Maybe some parts you improve them. So this, as a refactor to this file, I would say let's split this file into 2 files. One would handle the views maybe by calling the endpoint. So for example, this one wouldn't even have to be here in this app.js, but we would have another file for our views. So this, like, by doing these kinds of things, you start improving and refactoring your code, because this is not an endpoint of a web service REST API call. But of course, you need this function somewhere, but the architectural place to put this maybe not here. Okay. So this is what I changed, as I said, so that in the end, I will show you the code. For example, here, when I'm testing the list of people, if I can get it, first, think that like I don't even know what is inside the database. It could be completely empty and I don't know what to expect from it as well. So first I should do something. I should add this person by calling the API end to create a person, like we did, almost like we did last week with Axios, but in another format. So how we do it is with the super test. We had the framework, the package we installed. So we have a request. This means a call, like web service call request. So we call this person endpoint with a post request. We send the data that we created here. This is a JSON format. And we send this. We do the request here, sorry, and then we get a response here. We can also write something here, right? Because this is a call. Here, I'm only testing getting list of people. I'm not testing creating a person. Where I would check that is here. Because creating a new person, if I'm testing that one, I would write a new test. And then I would call the request as I did before as well. And then I would check the response of it. If it's 200, and if the response of the body like gives me the name of Arma and also the age of 33. So is this clear? Does this make sense?
So if you think about the end-to-end testing that we talked about in the previous hour, the goal is to make sure you test all of your functionality step by step. One step is creating a new person, because that's something that your application can do. Plan is basically telling Ava how many assertions you have, how many is calls, or how many fail, or how many pass calls you have. It's not super relative, and like it's actually not exactly needed. But sometimes when you have 20 tests, 30 tests running a single test, and you don't exactly know how many of them you have because you're generating them with, let's say randomly, you plan first and tell Ava to stop after it reaches that number. If you have 3 answers, just stop, because for me it's enough. I plan for 3 tests. If you have 3, just stop. If there are 4 responses, there might be a problem. It might be signaling you that there's a problem because you plan for 3 and you have 2 or you have 4. It's not super necessary, but it also prevents you from accidentally putting more assertions in a test file or in a test than you would expect.
You don't have to write it at the beginning. You can just write like this, and then you can edit to be sure that these 3 of them are passing. Because sometimes you have some cases of, you do a call and you never get a response. Then this should be a fail, right? But it doesn't even say it, because it doesn't even say that this test failed, because also actually I expect this whole steps to run. So this T plan 3 also fits to my expectation. I expect all these lines, all these assertions are passed as well. So,
and if for any reason they don't, your plan fails and your test will fail. So you kind of have a second check of, are you meeting your expectations internally as well? But it's nothing to worry about that much. My point was, you test your application functionality by functionality. If you should be able to create a new person, then you should have a test for it, right? This is what we have in an end-to-end test. If creating a person is an isolated functionality that your application offers, you have to have a test for it. And on the screen, you see in this test, we're testing if we're able to create a new person. And we only do that by creating a new object, sending it to our API, and checking the response of the API. And if you are able to create that person, right? But obviously, you might have other functionality, like getting a list of people. Now, the best way to do that is to start with an empty database,
to create one or two people, and then to fetch the list of those people, so that you make sure you're not dealing with an old database, with a pre-filled database, with a database that has other data, that has other objects. But you start with a clean database, you create a person, you get the list of people that should be in the system, and you see if you got the person that you created. So that's why, in fact, getting the list of people kind of includes creating the person, right? Because in order to test cleanly, if you're able to get the list of people, you first need to create a person. Now, that's why you see we have two different calls here. First, we create the person, and then we list all people and check if what we get is an array, and if there is more than one person inside that array, right? That kind of makes sense. Now, what you could do is you can delete the next test, create new person, because you're almost checking for a person creation in get list of people. Would it work?
Then maybe you would need to.
Please.
We have sync functions, and is it going to make some trouble during test if there's already?
No, it's just going to work.
I didn't understand the question.
If we have async functions, will they cause any trouble while we run them? Because we also run them asynchronously or in parallel. No, they're all going to work as you expect them to work. That's the beauty of AWA. It's very straightforward to use. It will work as you expect it to work. And you can use as many awaits as you want. And it will
work line by line.
Yeah, it will work line by line for that test. And the tests will run in parallel. Like in this case, creating a person and getting the list of people are two separate tests. They're going to run in parallel. But inside each test, it's of course going to run line by line.
If one test is like creating a person takes some more time, and the test is there, so like would be there some mistakes?
No, that won't.
Actually,
That's why I say it will work exactly as you expect it to work. So even though it runs in parallel, there won't be any trouble.
They are isolated. Here you can see it that like they are parallel because I have two test files. One is for meetup, the other one is for person, and you can see the times. And probably this took more time, and like you can see that it's taking them and then running them, and it's not in an order.
So
for
first
example,
you have meetup person, meetup person, meetup person. One test from meetup file, one test from person file.
Yeah,
right?
this is a good example because at the beginning of my test file was get list of people, but it took more time, so it finished at the fourth order.
Exactly.
And,
This is
yeah.
my question.
And it's not gonna cause any trouble because your tests are isolated. And they don't depend on the output of other tests. That's why to get a list of people, we first create the person inside that test. We don't only get the list of people, but we also create the people as well.
Yeah, of course, in one test, if you delete everybody, of course this would affect the other tests at that moment, right? But in a way, you shouldn't write it that way. You should isolate your tests based on what you have. If you want to delete, for example, we delete a person here. Again, we first create it and then delete that one, exactly that one, because we get this created person, we assign it to a new constant, and then we get the ID of it and delete that specific one.
So not any person, but in order to test deletion, you first create a person.
So you said to isolate the test. So can you please explain how if this code is test isolated? So how?
So this is how you isolate them. They don't depend on other tests. Even the deletion,
ideally, you would expect the database is full, and you already have an ID of a record in the database, and you delete that, right? What happens if you run the test again? You deleted it the first time. The second time, there are no more records in the database with that ID. Your test will fail. In fact, your code is correct. It's working. So by being very careful of our tests, which means by creating a person that we're going to delete and then deleting that person, we isolate our test. Now, no one else can affect my code, my test, because I'm not depending on an existing database. I'm not depending on another test. I want to test the scenario of deleting a person. For that, you have to have a person. And I first create that person and then delete that person. So in a single test, basically, I'm doing everything that's required to run that test separated from everything else. Even if you don't have a database, this is going to run. Even if you have an empty database, this is going to run because you're creating what you need to test first. So that is why we don't define the ID of the person. Even if it's there, as long as you don't have unique name checks or whatever, you're going to create a new person every time with the same name, but with a different ID, and you're going to be able to delete that person.
And if you would have a name constraint to be unique, you can also create your test users with random names. So there are some, frameworks or best practices which can provide you random names as well, or like user mocks and stuff that you can use. In this case, our database doesn't care about the name. We can create 10,000 armams, and we get the created ones.
The world would suffer.
Yeah, we get the person which is just created, and then we delete that specific one with the ID. And then we check, after the deletion, we check if we can fetch it, and we see we got 404. So this was what I said at the very beginning. You can always check the status of the server services that you have, or the response of the body of the response, if it's the created person, you can check if the name is aligned or the age is aligned. So we have just 10 minutes left, and I want to...
Are you sure the recording is going on?
Yes.
Yeah, it is.
And again, we have the recording from the previous year as well. So I know this is a bit,
a bit
a little
different,
fast and different. So watch the video from last year as well, in addition to this one, to make sure you have a bigger picture of testing in your mind. Any questions so far about testing? Sure. Yes. Yeah.
Where is the super test?
I mean, the request function is actually super test.
Yeah, here. It's the Mongo. Mongo's.
You're gonna see it when you do the homework.
Yeah, I know.
No, we don't. This is an end-to-end test, so we don't use any mocks here. Right? It's not an integration test. We're actually like for these tests, you need a mobile device.
Okay, so when we come back to this screen that we mentioned that, it shows me the coverage, the code coverage and the line coverage. It also tells me about the lines which are not covered. And I see here the lines, and I can go and check it. And when I come to here, which was telling me that like 81, 82, it's not covered. And I see that, yeah, I didn't write any tests for adding an attendee to a meetup. I just wrote tests for creating, getting, deleting, that kind of things, but not adding an attendee. So now we will write the test for this. I think this in which folder you should write this is based on your architecture again. But I think since it's adding an attendee to the meetup, it makes sense to have it in the meetup test, because it's a test of the meetup that I can add an attendee to the meetup. Okay. So you just start by giving a name to it. You can just listen to me now because I will push this.
Hard.
Okay,
So what we do is we want to test a user attending a meetup. The
Yeah,
name
we can
is
say-
user. Sorry, user can attend to a meetup.
Mm-hmm.
And again, T fetero is how we already start. However, we're now doing end-to-end tests, and they depend on our APIs, right? APIs are provided by web servers that are asynchronous in nature. We have a database involved, so we're gonna go to a database, fetch some records, add records to it, and then change the records, etc. This is gonna take time, which means this is an asynchronous operation. That's why before the T, you put the keyword async. Don't forget this in your homeworks. You're gonna need that as well because you're gonna write end-to-end tests. If you forget to put async before T, you'll try to run it synchronously and you'll not get any output and it won't work. So this is an async function. This is an async test that depends on asynchronous operations and web services. All right. We basically first create a user. We're gonna create a meetup, and we're gonna basically ask our API to add that person to the meetup.
And the meetup is like, it says I have the, let's say it's the VTM testing meetup, and it also has a parameter of location, which is your stuff, right?
Yes.
And we have the attendees. And at the beginning, I just say there is no attendee. And I should now call my person create request. Maybe I should just close this as well, so it's easier to check. And this is what kind of a request is this?
Asynchronous one?
Yeah, but it's post or get? The post one.
Oh yeah, that's a hard question. Whenever we're creating a resource, we're doing a post request.
Yeah.
Right. If you remember the verbs, the HTTP verbs that are like post, get, delete, put, right? And to create a new resource, you use the post one. Yeah.
Yeah, this is the
And
response.
You get the response and the body of the response. So you send it, and then you get the body of the response. The parentheses around the rate is what is kind of executing it.
Yeah, we could also let's do this one like that, so it's easier to understand. And then we send it to the meetup.
So again, in order to test the attendance function, you have to create the meetup, the user, and have the user attend to the meetup, right? You cannot depend on the output of the create user test. You cannot depend on the output of the create meetup test in order to test this functionality. You cannot assume that there's an existing user. You cannot assume that there's an existing meetup. You have to create all of those from scratch.
You have to create the meetup and the user that you want to test for, and then ask that user to attend that.
So you can either do like this, or do it first, getting the response, and then getting the body of the response. So I just add it inside the parentheses and write body. So this
Basically
is
a
another
different
way.
syntax of
Writing it.
And when you later get the code on your own, you can check the differences and pick whatever you want. They're both okay. The first one is a little bit shorter. The second one is more understandable.
Okay, so far I didn't write any assertions, because whatever I had so far is the things that I need to start testing. A user and a meetup. Now I'm writing what I will test, which is the endpoint of attendee. So what I do is, like, let's say so it is again a call. And it is again a post request, because I need to call an endpoint and send the attendee information in the JSON format in the post request. So this is, the endpoint is this. It is something already Emmanuel did last week. He defined this. Sorry, not like this, because we have the permission. So it's meetup, and then the created meetup ID, which is this created meetups ID, and then add attendee. Okay, so this is what I called, and what I should send it to it is the person. So we can check, like sometimes we can't remember this. I have it on the side, but we can also check it. How was my call? And I can see that it gets an ID, the person's ID. So this is the parameter that I should use to call the post. So here, I just go to here, and I say, okay, I will just use Anya's ID. Huh?
Not that one.
Yeah.
It's created. Person created.
Yeah. Oops.
Person created.
It's not good naming. So let's say created Anya. This person. So it's the created person's ID. Okay. So here, now I should check if this endpoint worked. So now I can write my assertions, which says, okay, I expect this response. The status of it should be 200. So we just start with this. Let's see if it fails or not. Where is it? Okay. Yeah, just right here, it's easier to see it. Okay, so it says it passed. By the way, I was not expecting this. Let's just yeah, it's just like it gives the 200 now.
Yeah.
But yeah, it's good.
This is very important. I know it's a little bit late, so bear with us for like a couple of more minutes. This is very important. You might have a lot of green check marks. They don't mean that your code or your tests are actually doing what they are supposed to do. We're checking if the response status is 200. That means if the API call succeeded. That doesn't mean that we're checking if we were able to actually have that person attend to that meetup. We didn't check for it yet. So having green check marks doesn't mean that you're good to go. It doesn't mean that the job is done. it's finished yet. So you have to add further assertions to make sure that that actually was the case. So we're now going to look at the body of the
response.
request that we sent, the response for the altered meetup, so that we should see that it has the attendees of 1, and the ID of that first attendee is the ID of the created Anya.
Okay, let's first start with is and then see that it's not working. We should have done this before even. Okay, so I have the meetup, the result, which is the patched one.
Attendee 0.
Sorry, patched attendee
0.
And the first one of it. And
underscore, then you can just use ID, underscore ID.
Yeah, okay.
And then it's created Anya dot underscore ID. Created person, I think. Created person dot underscore ID. And when you save it,
this one doesn't have watch.
It does, but it's npm run test watch. It's
yeah. I can also add it there. Okay, it also passed. So it means this worked. But we will, But we will try one more thing. Okay, what would happen if I would just say, okay, let's don't compare the IDs, but just compare the whole person if it's the same. What would happen? What do you think? Would it be passing? It failed. It failed.
Okay, and it already tells you why it failed. It says values are deeply equal to each other, like they're really into each other, deeply equal, but they're not the same. Well, this means that you have two different objects whose fields are exactly the same, but they're not the same objects. The references are different. They are created at different times. They hold the same information, the same ID, the same name, the same surname, whatever, the same age. However, they are different objects. So, yeah. So the idea is there is a different method to test for these, and this is what you're gonna probably have to use in your homeworks as well. Instead of the is method, which checks for being exactly equal, we're gonna use deep equal method, which will just compare properties of two different objects.
What about JSON?
That would work, but that's not a very good idea. Because there are some things that you cannot stringify. And the idea is when you use deep equals, the tests are going to pass. Why? Because we're now checking only for the fields, if the ages are the same, if the names are the same, if the IDs are the same, which they are, but we don't check if the objects are the same. Like, are they the same object in the memory? We don't check for that. So when you're checking the output of an API with an object that you have in your hand, when you're checking what you fetched from the API with an object that you have in your hand, you should use deep equals and not is as a method.
Yeah, because here we define a constant and the other one is another constant. These are two different constants. Even they have the same value in the end, they are not the same thing. So for that we use deep equal. We could also use, to test this, we could also say deep not deep equal, sorry, to check the altered and the created one. So first I created this meetup, but it's not the same anymore. And when I run this,
Why are they not the same? Meetup altered and meetup created. We added an attendee, right?
We could also check
Let's just-
attendees.length.
Yeah, let's just check for deep equal maybe. No, let's check for the deep equal. It's
Yeah.
even better.
Because it's going to show you the difference.
Yeah. So we go and check. I see that like this was not even there before because there were no attendees before and there is an attendee now. So for that I can use, okay, the created meetup should not be the same, the deep equal of the altered one. So for that I can use not deep equal. This wouldn't be something that you use so much, but T deep equal, and maybe like pass, fail, or not. These are things that you would use quite often.
All right. This is kind of the end for today. Sorry for taking a little bit longer than expected. Hopefully we could clarify the mystery around testing and how it should work like.
Yeah, I want to also show one more thing. If we go back to here, where was that? Yeah, we saw that like 81 and 82 was not covered and the percentage. And then when we started covering it, it became green. It was yellow. Here.
Yeah, from 78%
Yeah.
we raised it to 82%.
So this is how you try to increase more and more code coverage. And I will add these to the master branch again.
Yeah, so hopefully when you pull the master branch again tomorrow, you're gonna get the latest tests and be able to play with it. Now for the homework. Please continue working on your projects because you're gonna present them on 5th of December. And please add tests, at least for one file, for one module. Try to have 100% code coverage. You know, that like this, 100% of code coverage for per services and stuff. And that there are no yellow numbers, all right? Again, let's discuss if there are anything that's left unclear. Let's discuss them on the channel. Thank you.